Here's an example of a system of equations with three variables. So if you notice, I have x's, y's, and z's, and I have three different equations. So the first thing I want to do is I'm just going to label them for us as equations 1, 2, and 3, so that way when I refer to them throughout the video, you know which one I'm speaking with. So your goal when you are solving a three-variable system is to take two equations and cancel out a variable, and then take another two equations and cancel out that same variable. So if I'm looking at these variables, they're all stacked nice and neatly on top of each other. X is in one column, y is in another column, and z is in another column. If I look at them, in order to cancel, the z's look the easiest because the z's all have the same coefficient with different signs. So I'm going to label my steps as I go. Step 1, I am going to use equations 1 and 2, and I'm going to eliminate z. So you can eliminate y, you can eliminate x, you can pair up equations 1 and 3. There's a whole bunch of different ways to do this, but you should get the same answer. The steps will be a little different along the way, but your x, y, and z in the end will be the same. So I'm starting with 2x plus 3y minus z equals 5, and 4x minus y minus z equals -1. So if I want to cancel the z's, right now I would need to multiply by a -1. So I'm going to multiply everything in that bottom equation by a -1. And when I do that, my top equation stays, and my bottom equation becomes a -4x plus y plus z equals a +1. So now I'm going to add them together. So 2x minus 4x gives me a -2x. 3y plus 3y plus y gives me a 4y. And -z and a +z cancel. And then I have 5 plus 1, which gives me 6. So now I'm going to leave that alone for a second. If you want to, you can label it as equation A, but I'm just going to leave it right there for a second. Now I'm going to do the same thing, except I'm going to pair two different equations together. So I'm going to take a look at equations 2 and 3, and once again I want to eliminate z. So equation 2 was 4x minus y minus z equals -1, and equation 3 was x plus 4y plus z equals 12. So if I'm trying to eliminate z, I can do that right now because I have a -z and a +z. So when I go to add these two equations together, I'm going to get 4x plus x, which gives me 5x, -y plus 4y, which gives me a +3y. My z's cancel, and I get -1 plus 12, which is 11. So now I have that equation I just found before, the -2x minus 4y equals 6, and I have this equation that I just found. So that's going to be my step 3. So my step 3 is to solve the two-variable system. So I have -2x plus 4y equals 6, and 5x plus 3y equals 11. So now you're going to try to cancel either x or y. I'm going to cancel x only because my signs are already opposite. So I'm going to multiply the top one by a 5 and the bottom one by a 2. So when I do that, I'm going to get -10x plus 20y equals 30. And I'm going to get a +10x plus 6y equals 22. So now I'm going to add these two together. So when I do that, my x's cancel. I'm going to get 26y equals 52. Divide by 26 on both sides. So I'm going to get y equals 2. So now I need to plug back in to find x. So step 4 is to find x. So I'm using one of those equations from the two variable system. So if I use the first one, I have negative 2x plus 4y equals 6, but we just found that y equals 2. So negative 2x plus 4 times 2 equals 6. Negative 2x plus 8 equals 6. Subtract 8 on both sides. So negative 2x equals negative 2. And divide by that negative 2. So x equals 1. And now I have an x, I have a y, but remember we started with 3 variables, so I now need to find z. So to find z, you have to plug into an original equation. So I'm going to plug into equation number 1, which is 2x plus 3y minus z equals 5. So 2 times 1, because we just found x was 1, plus 3 times 2, because before we said y was 2, minus z equals 5. So this whole piece, 2 times 1 plus 3 times 2, gives me 8. So I have 8 minus z equals, let's move this out of the way, 8 minus z equals 5. So subtract 8 on both sides. Negative z equals negative 3. And then remember, there's an imaginary 1 here. So divide by negative 1, z equals 3. So you can write this as x equals 1, y equals 2, z equals 3, or you can write them as an ordered pair. So ordered pairs always go in alphabetical order. So it would be 1, 2, 3. So either of those is your answer. And you can always check your answer by going back to the original 3 equations and plugging in for x, y, and z and making sure all 3 equations are true statements when you substitute.